All right, so here we are. I don't know why my video's not showing. I think it might be because, yeah, it might be because I was in a Zoom meeting just now when I started this. I'm not sure, but it doesn't really matter for this one. So we have, first question is Fundamental Theorem of Calculus Part 2. So before we can find f prime of 2, we need to find f prime of x. So before we can find f prime of 2, we need to find f prime of x. And from here, we'll plug that in, and we'll get 1 times the square root of x cubed plus 1. Now we can plug in 2, and that gives us the square root of 8, right? 2 cubed is 8 plus 1, which the square root of 9 is 3. Now, I know technically you could have plus or minus 3. Remember, it's a function, though. So if you have f of x equals the square root of x cubed plus 1, that's all the positive sides. For it to give a negative answer, we would have needed to have a negative in front of the square root. That would have been the negative side. So this is the positive 3 choice. Next up, we have if dy dx equals 4y, and if y equals 4 when x equals 0. So that's kind of our initial condition. So we have 4y. By the way, if you guys are watching and you have any questions, feel free to put them in the chat, and I'll go back and answer them. So multiply both sides by dx, divide both sides by y. If you divide it by 4y, you'll still get the right answer, but it's easier to just divide by y. So this gives us dy over y equals 4 dx. And again, if you want me to show anything extra, like if someone's like, hey, can you show what happens if you divide by 4y? Just put that in the chat and I'll help you guys out. Right? If you did yours a little bit differently and you're like, hey, would this have worked? This is how I did it. Again, just add that to the chat. Integral of 1 over y is ln of y. Integral of 4 is 4x plus c. Now we're going to take e to both sides, e to the power of both sides. That cancels out. We take our c and we bring it into the front. This gives us y equals, when we bring the c into the front, that also allows us to drop the absolute value signs because c could have been positive or negative. And then we plug in 4 and 0 for the x. That goes to 1. So 4 is equal to c. Then we can just plug that right back in there. We get y equals 4e to the 4x, which was choice A. There we go. All right, so there's our video. All right, next up we have question 3. Shown above is a slope field for which of the following differential equations? There are a lot of different ways to do this, but the way I really like to do it is to just plug in a point from each quadrant. So I'm going to start off plugging in 1, 1, right? 1 for x, 1 for y. That's somewhere around here, right? 1, 1, which is an increasing positive slope. So I should get a positive dy dx. Okay, plug in 1, positive. 4 minus 1 is 3, which is positive. Positive times a positive is positive. Y is positive, 1 is positive. 1 times 4 minus 1 is also positive, right? Like 1 times 3. This would be 1 times 1 times 3, also positive. 1 squared is 1. 1 squared is 1 times 3 is positive. 1 times 1 squared times 3 is also positive. So this didn't help me out at all. All of them worked. Not a big deal. Let's go into the second quadrant. So negative 1, positive 1. Somewhere in there, negative 1, comma positive 1 also gives a positive slope, an increasing slope. It's going up and down, right? Like to the right. So as I go to the right, it's going up. Okay, so x is negative 1 this time. Negative 1 times 3 is negative, right? But I wanted to have a positive slope, so we're going to cross out choice A. Okay, y is 1. 1 times 3 is positive. B is still in play. We could still have B as an answer because it's a positive slope. Negative 1 times 3 is negative. We can cross out choice C. 1 squared times 3 is positive again. D is still in play. Negative 1 times 1 squared times 3 is negative, right? Because of that negative 1. So I can cross out E. Now I'm down to just B and D. So now let's try the third quadrant. So third quadrant, -1, -1. Again, that's an increasing slope, right? That's increasing, and as I go to the right, it's going up. So when I plug in -1 and -1, I should get another positive slope. So -1 times 3, or 5. -1 times 4 minus -1 would be -1 times 5. Either way, though, it's negative, so I can cross out B. -1 squared times 4 minus -1, that's 1 times 5, is a positive slope, 5/4. So choice D works. Right. So again, that's kind of the way I like to do it. Some people will look at like the 0, right, this line, and see like what's above it and what's below it and try to figure it out, but it always works if you just kind of go one quadrant at a time. You'll always get to your answer. It just might take a little bit longer. All right, next up, the graph of the piecewise function is shown, and they give us this h of x graph, and they want to know when is h increasing. H increasing is when h prime is positive. So we need to figure out what h prime of x is. Right, this is that second fundamental theorem of calculus. So I'm going to write h prime of x is equal to f of x. That's the y values. So when are these y values positive? Well, that's in between 3 and 9. I think that one was hopefully a pretty easy question. It's just really making sure that we kind of wrote this down and connected that concept. Okay, next up, this one was definitely just tricky. It took a little while. So I'm going to start off by multiplying both sides by dx, and I'm just going to divide by the y. I'm not going to divide by the 2y. If you did divide by the 2y, you'll get the right answer. But I always find it easy to do as little on the y side as possible. So I'm going to do times dx, I can extend that over, times dx, and then I'm just going to divide by y and divide by y. Again, if you divided by 2y, you will get the right answer. It's just simpler to divide by y. Now we'll take the integral of both sides. Integral of the left side is nice and easy. We get ln of y. But on the right side, it's a little trickier. But if you notice, anytime I have a denominator with an x in it, I always like to try u sub with that denominator. So the u would be 2x plus 1. That makes our du 2 dx. I already have the 2 dx, right? So that 2 dx, that is my du. So this now turns into the integral of 1 over u, right? This became my u, du. So that gives me the ln of y equals the ln of u plus c. That'll turn into the ln of y equals the ln of 2x plus 1 plus c. Now, if you got kind of stuck here, one thing you can try to do is cross out things. And we could definitely cross out c and d because there's no square root anywhere. And then at least, instead of guessing between 5, you're guessing between 3. You also may be able to cross out some of the other ones, but we'll get there. Anyways, now I'm going to do e to the power of both sides. Bring this c into the front. Those cancel out. And I'm going to just rewrite this first as y equals, remember we dropped the absolute value because we brought the c in front, c e to the power of ln of 2x plus 1. And now we'll see that the e and the ln are next to each other. Those cancel out. So this gives me y is equal to c times 2x plus 1. When they cancel out, they're being multiplied. So c times 2x plus 1. Now we're going to plug in our initial. So e for the y and 0 for the x. So e is equal to c times 2 times 0 plus 1. That's e is equal to c, right? 2 times 0 is 0, plus 1 is 1. C times 1 is 1. So we're going to plug that back in. And that gives us y is equal to e times 2x plus 1. That's my answer. Now, looking at these, the only one that kind of remotely looks the same is b. And we can see if we distribute, this becomes y equals 2ex plus e. So that was choice B. Definitely a lot of places you could have gotten lost or stuck here. It was definitely a trickier question that took a little bit longer. But we have the tools to do this one if we're careful and if we kind of make the right choice with our doing our U sub up there. But this one was probably one of the harder questions on the test. It was balanced out though. I think questions 1 through 4 were honestly pretty easy, and so is question 6. So this one is asking us to kind of match up with U sub. So integral from 0 to 4 of x e to the x squared dx. We're going to make our u whatever is the exponent in our exponential, so x squared. We'll make our du 2x dx. Immediately, what we should kind of look at first is our endpoints. We always want to plug in our endpoints on this question, right? Because they're kind of asking what was the proper u sub. So our endpoints are going to become the integral from 0 to 16. Immediately, this means I can cancel out every single option except for b and e. Then I need a 2x dx for my du, so I need to multiply times 2 and times 1/2, which gives me 1/2 integral from 0 to 16 of e to the u du. So that was choice B. All right, next up is 7. 7 was probably the hardest question on this multiple choice. And for 7, they said during optimal conditions, the rate of change of the population of a certain organism is proportional to the population. When you're proportional to itself, that is that dy dt equals ky, which gives the equation y equals y naught e to the kt. So we can use that as our equation. So at time 0, the population was 300. So that's our y naught. Okay? That's our initial. So you can say y equals 300 e to the k times t. Then from there, right, they say at time 24, the population is 1,000. So we can plug in 1,000 for the y and 24 for the t. And this is going to help us to solve for the k. So I'm going to divide both sides by 300. And we get 10/3, right? Those cancel. So 10/3 equals e to the 24k. Now I'm trying to isolate for k, so I'm going to take the ln of both sides. And we get the ln of 10/3 is equal to 24k. Now I'll divide both sides by 24. Now, if you got this far but got stuck after this, the only one that really has the ln of 10/3 in it is choice D. So from here, I'm thinking it's probably choice D. We're not 100%, but that's the only one with the ln of 10/3, and this was a non-calculator question. So if you got stuck, but at least you got this far, you could at least try choice D as the one that you're going to guess with. Anyways, from here, I'm going to plug this back in to the equation. I'm going to use a different color. So now we have y equals 300 e to the ln of 10/3 over 24 times t. And then we want to see at what time t is the population 500. Remember, the population were our y's. So we're plugging in for y, and we're trying to solve for the t. This gets really, really messy when we're doing it by hand. This is much easier when you're doing it on a calculator. Okay, so we can cancel out those zeros, divide both sides by 3. We get 5/3 equals e to the power of the ln of 10/3 over 24 times t. Now I want to get rid of my e, so I'm going to take the ln of both sides to cancel out that e, and that gives us the ln of 5/3 equals, and I'm going to kind of write it this way since they have it as 1/24 ln of 10/3, just to kind of show how they wrote it. And they divided both sides by the 1/24 ln of 10/3. If you had multiplied by the reciprocal times 24 over ln of 10/3, you'll get the same thing. But I'm just kind of showing how they did it. So that was their answer, right? That's equal to t. Okay, pretty nasty, but like I said, questions 5 and 7 were definitely tougher, but I think the other 5 questions on here were easier, and that's a lot of times how the AP test works out. Now, I did add an 8th question. There was a non-bonus question because I just wanted to have one more slope field question in here, and I thought it kind of made sense to have 8 here. So this here is actually a distractor. Okay? So it tells us y equals g of x is the solution to the differential equation. G of -2 equals -1. And I even gave you a hint here. This was from an AP test, but this part wasn't on the AP test. So at -2, -1, what would, if we drew this graph, and we can kind of see there's an asymptote here, right? There's an asymptote right there because there's nothing, right? So as we go out to infinity, that's all the way to the right, this graph is approaching 0, right? Because it has an asymptote, so this would be choice C. So you didn't have to do anything other than kind of graphing it and then looking at what is this approaching all the way to the right. So kind of tricky to graph it because you did have to realize that asymptote there. But that was our answer. Next up, bonus 9. I'm going to go ahead and skip. Honestly, it's too nasty. Hopefully no one tried it. It's something that I threw on there mostly just to see who was really, really working fast. But let's go ahead and skip that one. If you really want to know it, I can talk to you about it. But honestly, it's not something that's worth wasting our time when we're doing a kind of going over this. I will go over bonus 10 though. So bonus 10, the u is going to be kind of the most complicated inside piece, which is that tangent of x. The derivative of tangent of x is secant squared of x. What you had to realize on this one is that secant squared is the same as 1 over cosine, right? Like secant of x is 1 over cosine. So in this case, we already have that. I can just rewrite this as, essentially secant squared of x, because I could bring up the cosine squared, e to the power of tangent of x dx. That would have been the same thing, right? From 0 to pi over 4. So now the u is going to be the tangent of x piece, and then the du will be the secant squared of x dx part. So this now turns into the integral of e to the u du. And then I'm going to plug in my endpoints. Tangent of 0 is 0. And tangent of pi over 4 is 1. So this becomes e to the u from 0 to 1, which is e to the 1 minus e to the 0. Anything to the 0th power is just 1. So it's e minus 1. And then for my dog's middle name, it was actually none of these. He's a dog. He doesn't have a middle name. Although Day says that dogs can have a middle name. So I guess my comment was only partially true, but he still does not have one. All right. Let f be the function given by f of x equals the ln of x times sine x. The figure above shows the graph of f. And so we want to find g of 1 and g prime of 1. And as a bonus, I said find g double prime of 1. So g of 1 is going to be the integral from 1 to 1 of f of t dt, which on the graph would be the area from 1 to 1. But whenever you have the endpoints being the same, it's just 0. Right? My endpoints are 0. There's no space in between 1 and 1. To find g prime of 1, first we need to find g prime of x, right? Which would be f of x. This is very important. Like this line right there is always worth a point. If you didn't write that line, you're going to miss a point on this question. You need to show that work. You need to write that. So if you didn't write that, you lost a point. So make sure you add that to your corrections. So then g prime of x would be, g prime of 1 would be f of 1, which is the y value at 1, which is actually also 0, right? The y value at 1 is 0. But if you didn't write this line, or you didn't write f of 1, right? You need to at least have f of 1 or f of x, equal to it. You lost a point, and add that to your test corrections. Right? Then g double prime of x, the bonus, we'll kind of do that one. I'll do it in another color because it was bonus. So g double prime of x will be f prime of x right? And the issue is I can't do that on the graph. Normally on the graph, we say that's the slope, but we can't really draw this on the graph. It's not linear. We can't do like up 2 over 1. But what I can do is use that equation. So we can say, okay, that's product rule. So 1 over x times sine of x plus ln of x times cosine of x. Right, that would have been product rule. So now g prime of 1 would be 1 over 1 times the sine of 1 plus the ln of 1 times the cosine of 1. Well, ln of 1 is 0, so g prime of 1 is just whatever the sine of 1 is. We would just leave our answer like that, sine of 1. Since it's non-calculator, that's as far as I can go. All right, next, on B, on what intervals, if any, is g increasing? So we need to make sure that we write g prime of x equals f of x. Again, if we don't write that, we're losing a point. That would be worth 1 point. Then from there, where is g increasing? Well, g is increasing wherever g prime is positive, which is wherever f is positive. Right, like g prime of x equals f of x. We want that to be positive if our graph is increasing, right? It's increasing when g prime is positive. So that's between 1 and now this one's a little bit hard, but because we see sine of x in there, we can kind of assume that this is pi, okay? 3.14. I probably should have written that for you guys, but I think it's kind of obvious that it's pi. If you put between 1 and 3, I'll still probably give you points, or if you guess something else like 3 point something, but that was pi. So g is increasing for 1 to pi because g prime of x equals f of x is positive for that interval. And next, how many points of inflection does the graph have? And so I even said during this that there's no way for us to actually know what they are. So inflection points are when g prime switches between increasing and decreasing, or when g double prime changes signs. So g double prime of x here would be equal to f prime of x, right? How many times does that change signs? So that would be, basically when f prime of x switches between increasing and decreasing, right there. Goes from decreasing to increasing, right here. The graph goes from increasing to decreasing, and then somewhere in here, the graph goes from decreasing to increasing. So that happened 3 times where g double prime equals to f prime of x changed. So we'll say how many inflection points? It has 3. So g has 3 inflection points because g double prime of x equals f prime of x changes signs 3 times over 0 less than x less than or equal to 2 pi. That's the simplest explanation. It's just g double prime of x equals f prime of x changes signs 3 times. If you really wanted to add, like the graph of f, changes decreasing to increasing to decreasing, right? Decreasing, increasing, decreasing, increasing. So that was like 1, 2, 3 times. You could have written something like that. Honestly, I think you're getting yourself more complicated. That's full credit and is nice and concise. All right. Anthony asked for part B. What if we had g prime of x equal f of x in the explanation? No, you don't need to have it up here. I like that. So if you have it right here, I think, Anthony, you're asking what if basically you only had that. You still get the point. Just basically this g prime of x equals f of x, this needs to be written somewhere, okay? So in this case, I wrote it twice. I wrote it just initially, and then I wrote it again in my explanation. If it's only in your explanation, you'll still get the point as long as it appears somewhere. That's a really good question. Thank you for asking that. And then part D, for 0 less than or x less than or equal to 2 pi, find the value of x at which g has an absolute minimum. Okay. So it's a little bit tricky, but again, started off by saying g prime of x equals f of x, which is equal to 0. This is super, super important. This, again, is worth 1 point. That line there is worth 1 point. Now, if you just put g prime of x equal to 0, you'll probably still get the point. But this is so much better to write the whole thing. So now, even if you didn't do anything else, everyone should have at least gotten that 1 point. Now from there, x is equal to, where does f of x equal 0? If we look at the graph, that happened at 1 and also at pi. So at 1 and at pi. So we're going to have x is equal to 1 and x is equal to pi. So now we're going to say x, and then we're going to put g of x. We're going to put in 0, 1, pi, and 2 pi, right? These are endpoints and our critical points. Now for g of x, this is actually really a tough question. And it's because it just says find the value of x. There's no way for us to actually solve for these, right? Because g of x was equal to the integral from 1 to x of f of t dt. So we can do, when we plugged in 1, we got 0. But from here, what we kind of have to realize is that this is kind of a negative change, right? But if we're going backwards, right, because we're starting at 1, if we're going backwards, this is actually going to increase positively, okay? Right? It would have been above 1. So because we were going backwards. So this is going to be some kind of a positive number. We're not sure what. Then if we're going forwards, right, I'll kind of use another color. So if we're starting again at 1 and we go forwards until we hit pi, this increased positively as well, but I'm going to give it like a bigger positive because you can see this area is bigger than that smaller area. So I'm going to say this is kind of like a bigger positive. I'll use, kind of maybe 2 pluses. And then this guy just had 1 plus. Then at 2 pi, what happens is we keep going. And again, we're at 0. We know that the value here is 0. And now we increase some, but then we decrease a lot more. So we increased, but this section is bigger. So this value is going to be negative, right? We increased, but then we decreased more. Kind of positives, or 2 positives, but then maybe like 3 negatives. So it's negative overall. So the absolute minimum value, right? That's what they wanted, will occur at x equals 2 pi. Right? And really, if you had a table like this and you kind of wrote positive, positive, and negative, you're good. We don't care what the values are. But if you want to kind of add, because g of x equals the integral from 1 to x of f of t dt, and g of 0, g of 1, and g of pi all have positive solutions, while g of 2 pi is negative. So again, this whole because is kind of optional. You could get full credit without writing it. Basically just having this written, and have some kind of a table, maybe accompanied by that equation, and then stating that the answer is at 2 pi will give you full credit here. So this is kind of just extra, is the explanation. Then E says for 0 to 2 pi, there's a value of x at which the graph of g is tangent to the x-axis. Oh, is there a value? Explain why or why not. I did leave this on here, but this is probably a really, really tough answer. I really don't expect that many of us got this answer. This was very, very difficult to think about. But basically they're saying, is there a value of x at which the graph is tangent to the x-axis? I want us to think about what that would mean. Okay, tangent to the x-axis would mean that the graph kind of touched the x-axis and had a slope of 0 along the x-axis. So what that means is it means that our y1 would end up being 0 and our m would end up being 0. Now, what is y1? y1 matches up with g of x. And m matches up with g prime of x. So g of x had to be 0 and g prime of x had to be 0. Now, if you go back and you look at part A, in part A, g of 1 was 0 and g prime of 1 was also 0. So this one is really, really tricky, but it's kind of just saying, oh yeah, in part A that happened. So we would say yes, because g of 1 equals 0 and g prime of 1 equals 0. So the graph of g is tangent to the x-axis at x equals 1. Okay, this was worth 1 point out of possible of, I think it was 8 or maybe even 16. I forgot what. But this was worth very, very little. It was kind of tricky to see. Again, most of us probably wouldn't have seen that. So don't sweat it too much if you didn't get this one right. And then what month was Emerson born in? Some of you guys said not February, since you knew she came on screen and said it wasn't her birthday. But she was born in the month of October. If you watched the second YouTube live, I think I said that in the second YouTube live towards the end. Anthony asked if I could post the template. Yeah, I can do that. So that template that I showed in class, I will post that to the classroom. I'll also just post the straight answers as well, if you need that. But yeah, thank you, Anthony, for helping out. Anthony, since you asked a question during the chat, if you want to put +1 at the top of your test corrections, I'll give you an extra credit for that homework assignment, okay? All right, so anyways, that's it. Hope this helped you guys, and I will see you guys in class tomorrow. This is due by midnight, the test corrections, by midnight.